Well, welcome everyone to Algebra 2, Section 3.3, Analyzing Functions. As you can probably already tell, my voice is not my normal self, and I am not feeling the best right now. But I'm still able to make this video, so that's why I'm here. If at any point I will need to sneeze, or I will need to blow my nose, or anything like that, I will warn you, ask you to mute the video, or ask that you mute the video during that time because you definitely do not want to hear that. And then I will do a little scribble on the screen so that way you can see I am done and you can unmute. Also, my voice might be going out at different points, so just be aware that there might be some things that are a little harder to hear, and I'll repeat a couple times because of that. Alright, without further ado, let's get on. Let's do the warm-up here. What type of function has no minimum or maximum values? Name one or draw a picture. Well, this would be a linear function. And a linear function, as the name indicates, is just a straight line. And they have no maximum end because they go up or down forever. Now, we have this graph over to the right. So we're asking, hey, the values in this function, as you can see, it's going up, down, up, down, up, down. From, on the interval specifically here, this domain, we're going to talk about here, or I should say interval, not domain. Because domain would be the entire thing for the x values. The interval, when 1 is less than x and 1 is 3, and x is less than 3, so x is between 1 and 3, so we're talking right here to right here, we're asking, not 0 to 3, 1 to 3. Are the values in the function positive or negative? Now, when we're talking about the values on the function, we're always talking about the y values, aka how up or down it is. So we're saying, hey, is it above 0 or below 0 for the y-axis? And it is positive. Next it's asking, hey, what about the interval 6 to 8? Is it increasing or decreasing between those two? So between 6 and 8, we can see that it is going down and it is decreasing. Once again, that is about the y values. What are the y values doing between this point and this point, left to right? So, what's the function's average rate of change on the interval 8 to 10? So, here we have 8 to 10. So, in order to find the average rate of change, we say, okay, the rise over run. Well, it goes by 0.5 or halves on the way up. So, we go up half, a whole, 1.5, and 2. So, we rise 2, and we run 1, 2. So, the average rate of change is 1, because 2 over 2 reduces to 1. Next, what is the value of the function at the points where the function changes from increasing to decreasing? So, we get to say, hey, where does it go from increasing to decreasing? Aka, where does it stop increasing? So, that's here, 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 or where it stops going up and starts going down. So, those values are 2, 6, and 10. How many x-intercepts or zeros? Sorry about that pause. I was wondering if I had made a mistake there, but I don't think I had. How many x-intercepts or zeros does the function have? So, it's the x-axis 1, 2, 3, 4, 5, 6 times. So, that's 6 x-intercepts or zeros in this case. Alright, I'm going to sneeze. There's me blow my nose. Alright, I am back. We are going again. So on to the actual notes today. And we're going to be talking a little bit more about that kind of stuff actually. So we're going to use this information in this paragraph. We're going to find the sketch a corresponding function and answer the questions that follow. So I'm going to ask you to read the paragraph and underline things that you think are important to know for the graph, and then graph it. But before you start graphing, I'm going to have you do that. I'm going to ask that you look at the y values and notice on the graph that it go up by 5s, the x values go up by 1, starting at years since 1974. And these are per 10,000 people for the y value. So please go ahead and pause the video and work on that. Okay, so things that I would drag out saying, okay, in 1974, there were 10 cases per 100,000 people. Okay? So that would be at 0 years since 1974, and this is per 10,000 people, so we start at 10. Next, we'll say, okay, from 1974 to 1980, there were drastic functions in the incidence of measles, so it's good to know. Then here's our next data point. In 1975, 1 year after, so we'll be at x is 1, slight increase. So, okay, we know there's a slight increase. But before we start graphing, we want to know, hey, how much does it increase to? Then it says the next 2 years had a substantial increase, so increased farther. And that reached a maximum in 1977 of 26 cases per 100,000 people. So we go over to 1977, which would be 1, 2, 3 years after 1974, and we go up to 26. It's okay, now in order to get there, we want a slight increase from 0 to 1 year after 1974, because it says 1974 had a slight increase, or 1975 there was a slight increase, and then a much steeper increase the next couple years. That's what it tells us, a more substantial increase. So I'm going to do just that, of going up slowly to start, and then really ramping up. Oh, I'm sorry. I made a mistake here that you might have noticed. Is I went at 4 years after rather than 3 years after. So it changes the way this graph looks. So a slight increase for the 1 year, and then a steep increase after that. And it might not look exactly like that. Maybe yours looks a little bit more like this. Okay, or even like this. As long as it gets steeper after a year, that's what really matters. Next, we say, okay, 1977, 1979, it fell about 5 cases. So it'd be 2 years farther from 1979. So it'd be over at 5, which would be 1977 to 1979. It'd be 2 years farther. And it dropped 5 cases down to 21. Connect those. Oops, I went 1 year after. Making mistakes all over the place. And connect those. Then it fell much faster from 1977 to 1978 than from 78 to 79. And then we're finally told, hey, from 1979 to 1980, that it stayed about the same. So, I made another mistake. I am so sorry. My mistake is that it didn't fall 5 cases. It fell about 5 cases. Fell to about 5 cases. So it was at 5 cases at that point. And then we're told that first year it fell faster than the second year. So, you can fall quickly and then fall slowly. Once again, Yours might look a little bit different, but as long as it's a much steeper decline from 3 to 4 as from 4 to 5, you're good. Sorry about that mistake. And then, last but not least, finally from 1979 to 1980, so from 5 to 6 on the graph, it stayed about the same. So, you just keep it there, over at 5. So now we have this graph. Once again, sorry about all of those mistakes along the way, but we finally got there. On the y-axis, up and down, the function will run from 5 to 26 cases. So that's the total number of cases. This represents the range. And we also note that, hey, the graph is horizontal from 1979 to 1980. Let me go back and talk about the range first. It represents the range because those are the lowest points and highest points on the graph. Low over here at 5, high up here at 26. So even though the graph starts at 0 up and down, and or shows from 0 up or down all the way up to 30 and beyond, that's what the values we actually see. Alright, now on letter B. It's horizontal from 1979 to 1980. So what does this tell you about the rate of change on this interval? Once again, I encourage you to try this one on your own. So I'll say, hey, the rate of change was constant, which means over the course of, as time kept going, it was 0 for the rate of change or the slope, because there would be 1 year of change on the bottom as you do rise or run, but 0 changes in cases, which would be reduced to 0. Now, as we flip to the next page, we are actually going to skip this and not do this. And that means we're also not going to do this page either. So, as you might notice, we're actually done with these notes for the day, believe it or not. It was